All right, we're going to get started for today. There's not a terribly large amount of new stuff that I'm going to cover today. I think there's been enough information thrown at you for the past week or so. So today is going to be more or less a review of stuff that we've gone over. We were supposed to go over like gems and NPM and all that kind of stuff today, but since we've already gone over it, it's just more or less going to be a review. I'm going to go over kind of like the roadmap of the week. We'll review anything that you wanted to review from yesterday's work, and then we'll go over today's stuff, and we'll be done. Just as a heads up, I need to be gone from 11:15 to around like 2, so I'll be gone for a little bit, and then I'm leaving at like 3:45. James, are you going to be here all day, or are you going to take off at a certain point?
I was going to take off, but I can be here.
Okay, we'll talk about it right after this.
All right. Is there a node environment like IRB?
There is. You can just type in node.
But I mean, is there a way to like import your function into?
Other than copy and paste, I don't have that. I don't know. Okay. So as we all know, tomorrow morning at 10 o'clock, the Road Home is going to be coming in. Road Home provides free mental health services in case you or your family ever need it. And I think at least some people from every group have gone so far. And if you, the intake process is long, so if you think you may need it later, you may want to just start right away after they come tomorrow. If you need to go down there, it's by Rush Hospital, which is about a 20-minute drive from here. And if you need to get there, we'll pay for your Uber rides there and your Uber rides back, so you don't have to worry about that. We just want to be here for you. Your first assessment is going to be on this Friday. It's going to be, if I recall correctly, it's one algorithm and one object-oriented challenge. It's not terribly difficult. You'll have the entire morning to do it. And in the afternoon, around 5:30, we're all going to, right around, probably you'll leave here with Kara around 5 or so, but we'll all go over to Hash Rocket, which is 661 West Lake Street. It'll probably take us about 20 minutes to walk there. And we're going to be there for the Chicago Veteran Developers Meetup. I think everyone here signed up, except for Mickey. Mickey, I'll send this to you separately, and I'll have you sign up for it. I'll be moderating a panel, and then there's going to be 2 developers there, one for Hash Rocket, one for TrustWave. Greg Jooms from Victor Tech, he's the CEO, and then the VP of Engineering for Hyatt Hotels as well. So that person will be there. For the rest of this week, let's kind of see what we've got. So week 2, Wednesday, Thursday, Friday. Tomorrow we're going to do regular expressions. It's going to be kind of the weird symbols that you see in between the front slashes. We'll go over it more tomorrow, but it's an all-day thing. You only need to really spend one day on it. You'll start recognizing patterns pretty soon. We're going to cover that all day tomorrow. Thursday, we'll talk about test-driven development and the importance of that when it comes to writing software in today's day and age. And then Friday, we won't cover anything, but we will have group projects over this weekend. So our first group project is going to start this Friday. We're going to split you up into 2 groups of 3, and I'm going to have you all do the solve Rudoku, which is Ruby Sudoku. So you're going to create a Sudoku solver that solves every possible Sudoku scenario. So if you don't know how to play Sudoku, you might want to get ready for that. Does anybody actually play Sudoku here? No.
You mean like the
numbers game?
Yeah.
Okay. Okay. Good. All right. I'm going to open this up now just to kind of see what people have questions on. Was there any recursion challenges you want me to go over? Did you want me to go over binary search? I haven't been able to do any pull requests quite yet. Everything is covered up to yesterday though. Is there one or the other that you would like me to go over this morning?
I was going to go over binary search later. But,
cool.
Back down to that, but.
Okay. Who has not finished binary search? 1, 2. Okay. All right. Well, let's cover binary search together. Then we'll cover the topics for today, and then we should be done less than an hour. All right, so I'm going to load up my IDE, my integrated development environment. Again, it consists of 3 components: my Google Chrome for all of my work and all of my Googling, my iTerm for all of my command line stuff. Change into the desktop. Actually, real quick, I forgot to fork. So what is git fork, and what does that do? Yeah. So when I fork it over to my username, it no longer exists at Delta Platoon / binary search. It's actually making a photocopy like this cute little graphic here, and it's basically making a copy on my own user. So I can push things up. I can push the master. It's another layer of abstraction, so I don't accidentally alter the original. Let me clone this down. So the command for cloning a repository is git clone. And what does git clone actually do? Yeah, it just downloads it from the internet down to your local machine. So if all goes well, I can cd into binary search, and then I can open this up in Sublime. Here we go. So I have 3 things. I have my Google Chrome, I have my terminal to execute my commands, and I have my text editor, Sublime Text or Atom, your choice. First things first, I don't think I want to be pushing onto master just in case anything happens. It's generally good practice never to work directly on master because other people could be working at it at the same time. So how do I get to a new branch? So I do git checkout -b, okay. Then let's just call this class example, binary search. All right, this git checkout -b will create a new branch for me, and then it'll automatically check out. Now I'm in a safe spot. You can kind of see I'm no longer on master, but I'm on this class example of binary search. All right, let's take a look at what's going on here. All right, let's read it on the internet because it's a little nicer there. All right. So the goal of binary search is to find the index of a value, passed in value compared to an array of strings or integers. Let's say, blah, blah. Okay. So the basic idea here is, if let me set it to Ruby. If I'm looking for a needle inside of a haystack, I could obviously start on one corner and go all the way to the other end and check every single one, but that has poor performance because I'm checking every single thing. The question you have to ask yourself is, can I split this in half so that it's slightly easier to find? So the way that the mechanics of the binary search is basically I have a target number, let's say it's 10, and then I have a array of random numbers. So if I have 1, 2, 3, 4, 5, and then 8, 10, 15, 20, 25, 40, and 50, I have to basically find where the target number is inside of this array. Now we've done linear search over the past few days, and basically what that was is I basically say I have this target number, and I'm going to iterate over every single thing until I get to 10. Or if I go through all the way, then it's not there. But the issue with this is right now it's manageable because we only have 10 numbers in here. What if it becomes 1 million numbers or 10 million numbers? The idea of software in general is I want to be able to scale it. I don't want to I don't want to just make it work. Just make it work is not going to work for something on the scale of Amazon. You don't want to just choose the easiest path. Sometimes you're going to have to find the most optimal path. All right, so here for binary search, the way that this is going to work is that you have to make sure first that your array is sorted. And basically what you're going to do is you're going to find the midpoint of the binary search and just cut it right down the middle. If it's equal to the middle number, great, you're finished. Just give me that index and you're done. If it is smaller or greater than the middle of the pack, let's say the middle of the pack is 8, and your target number is 10. If I split it right down the middle, obviously 8 is greater than 10, so I actually don't even need to worry about this first half anymore. And then I split this in half again. 10 is less than 20, so I don't have to worry about this half anymore. I split it in half. In this case, it's just going to be 10, and at that point you return the index. So you're splitting it down so that the amount of space that you're looking for gets cut in half every single time. All right. So first things first, we're going to start pseudocoding all of this out. So the first thing we're going to do is let's say we're going to create a method called binary search. 1A, the method takes in a number, like the target number, a sorted, let's just say an array of numbers. Okay. Second, let's see. What's the next thing that you did, John, for this?
So what we did is we took the array and divided it in half.
Okay.
Or the length divided by 2.
Okay.
Use that as your index to take a peek at what's in that spot.
Sure. Okay. Actually, let me grab a whiteboard real quick. Can you pass me one of those ones right behind you? Just to kind of go over it one more time to be absolutely certain that we all understand what the binary search is doing. Draw it out.
And we use floor as well.
Use floor. All right. So let's say I have the number 5, and I have an array of 1, 2, 3, 4, 5. The idea of the binary search is I have a fixed number of spots that I can look through. But right now it's only 5, but in the future it could be, 1 million, 10 million, 50 million. And if it was like the 50 millionth minus 1, then you just wasted a whole bunch of time. Or worse yet, it could also not be in the array at all, and then you're kind of screwed. The idea is I want to shrink this down as much as possible. So what I'll do is I'll cut the array right in half and take a look at that number right in the middle. If this number is greater, basically you compare your target number against that middle one. And again, this array is sorted. So you're going to say, hey, is 5 larger or less than 3? Since it's obviously greater than 3, I realize I don't have to worry about these first 3 numbers at all. I shrink it. So at this point, it now becomes 5, 4, and 5. If I split it right down the middle, like choose one of the sides, it's larger than 4. So I don't have to worry about this first half anymore. And finally, I get to the point where I go to 5, and then if I split it right down the middle, I take with that index, hey, is this the same thing? And then you'll continue shrinking down that, like the large pile of hay to find the needle. I'll leave that here.
I guess what you should do originally too, though, is to check if 5 is greater than or equal to array at 0 and less than or equal to array at length minus 1.
You could do that
because that way you listen to notice inside.
Yeah.
Continue. Otherwise, not there. So.
Yeah, that is definitely something we can put in there. 1 second. All right. So as we start all of our algorithms, we start with pseudocode. Pseudocode meaning human-readable code to basically walk yourself through it. I was telling someone this morning, basically, as a human being, you make a lot of inferences, and you can solve a lot of things because the human brain is amazing. Computers are very, very fast, but they're also very, very stupid. You have to tell them exactly what to do at all times. If you don't tell them exactly what to do, you're going to lose track. It just won't execute the proper way. So we want to create as much like pseudocode as possible so that we think through it twice, and then we only have to code once. We have to tell the computer exactly what to do. So my first thing here, I created a method called binary search, and the method takes in a target array and an array of numbers. We're going to measure the length of the array. If we kind of think through what we have down here on this whiteboard, we have the number 5 and an array of 1 through 5. We just kind of cut it right down the middle, meaning that we need to know what the length is and what the length divided by 2 is. Because the length of that first array is going to be 5, and when we divide it in half, you're going to get 2.5, and you're going to have to find that number right at the middle. So measure the length of the array and divide it in half, rounded. You can round it down or round it up. I'm just going to round it down. Divide it in half to figure out the midpoint index. I also need to figure out what the middle number is at that middle index. Next, I'm going to have to do a comparison. I'm going to say, is it greater than or is it less than that middle number? Is the number greater than or less than that middle number? 3a. If it's greater than the middle number, greater than, less than, or equal to. Equal to. If it's greater than the middle number, actually, if it's equal to the middle number, return the index, midpoint index, and you are done. You might be lucky. It might be like I'm looking for the number 3, and I cut it right in half, and then it gives me the number 3. Okay, we're done. We don't have to do anything else. You might be lucky. If it's greater than the middle number, then we just chop it right in half and only care about the right half. We're going to rerun the method, but this time only with the second half of the array. And then similarly, 3c, if it's smaller than, if it's less than the middle number, rerun the method, but this time only with the first half of the array. And then we're going to repeat until, at what point do I exit this case? This is going to be a recursive problem because we were going over recursion yesterday. But, until midpoint equals number. But what happens if if it's not in there? Like what if I said, I'm looking for 7 inside of that first one?
That's what John says, so that should be like the first conditional.
That could be a first conditional, yeah.
That doesn't really help if there are 2 to be, between those, but you might not have the value. Let's say you have numbers like 1 to 10, but only like 1, 3, 10, numbers 5. So it fits that criteria.
That's a good point.
You can't really, you can do the inclusion as a possibility.
Yeah. So like when we're thinking about this, like when would you stop? When would this be over?
So you're out of numbers or you find it?
The first one.
So you're out.
Yeah. Until either the number is found or there are no more numbers to compare against. How do we feel about the pseudocode here? Does this kind of make sense? We came up with all of our ideas and we just kind of put it out here. Okay, I'm going to comment all of this out and we'll start writing a few things. All right, so number 1, create a method called binary search. Done. Just one of those checklist things, and then I feel a little bit better about myself. 1a, the method takes in a target number and an array of numbers. So I'll just do target number, numbers, array. Cool, 1a is finished. Number 2, figure out the length of the array and divide it in half to figure out the midpoint index. Meaning, if I have the numbers 1, 2, 3, 4, 5, I want to find out what's the middle index, and then what is the number at the middle index. So the middle index for us is 2, because that's if I have a array of length 5, if I divide that in half, the midpoint index is going to be 2. and the number that it represents is going to be 3. So for me here, I'm going to do midpoint index equals numbers array dot length divided by 2, and I believe this automatically rounds down. We'll find out. IRB at 5 divided by 2 automatically rounds down. Ruby.
Yeah.
I didn't even do that.
Ruby, man.
Yeah.
So midpoint index, for this one right here, it's going to be 2, because I have like an array of 2, and then array length of 5, and I'm dividing a half to get 2. So the midpoint index is that. Now let's say the midpoint number or something like that is going to be numbers array at midpoint index. I think I have done that. So I finished all of 1 and all of 2. I'm on to number 3. Basically, we're asking the computer, is the number greater than, or less than, or equal to the middle number? So we'll have to have a bunch of if statements. If the target number is equal to the midpoint number, return midpoint index, and I believe that's it. Like, I think we're done at that point. Else, if the target number is greater than the midpoint number, then I'm going to rerun the whole thing. Rerun the midpoint index. Oh, wait. Rerun the method, but this time only with the second half of the array. So I'm going to do return binary search of target number. If it's greater than, I only want the midpoint all the way to the right. So that means numbers array starting at the midpoint, going up to the negative first index. Have people seen the negative first index before? So it's interesting. I got A is 1, 2, 3, 4, 5. I can access the last element, the number 5, by doing A of 4, because it's length 5, so that's the last one index is 4. But you can also, it also kind of circles around, which is kind of annoying. So I have 1, 2, 3, 4, 5 in succession. But if I do A of -1, it actually starts going backwards. So it starts from the right side and says, like, I have this array. I'm at the 0th index right here at 1. If I go to -1, it's actually the last one. It's a nice little trick that I picked up. I don't think you can do -2. Oh, you can. I'm kidding. What happens?
Basically, dot length.
It's good for the cipher then.
Yeah.
Yeah.
That's interesting. What was that?
Basically, dot length.
-1.
-1 is not the length. -1 is -1 is like I'm at the 0th place. I'm at 1. At the negative first place, I go all the way to the back of the array and go to the negative first space. It's a little trick. I don't know why they decided to do that, but it's nice and built in all languages actually, which is kind of nice. All right. So if the target number is greater than the midpoint, then I'm going to only care about the ones that are on the right side. And then else if target number is less than the midpoint number, I'm going to do the same thing, only I'm going to go from the beginning, which is the 0th, all the way up to the midpoint.
I don't know if you want to do this yet, but you might want to return for the second statement, the midpoint number plus that.
Ah, that is a good point. Can you explain that?
So if your recursive call eventually get to your final index, it's going to add up. Let's say every time you're cutting the second half, it's going to add up all the midpoints up until when it comes back into the stack.
Why is that?
Because you want your index to be the original array.
Yeah, it'll return.
Every time you cut the array, you lose it. You lose half of the original array, right? So your indices change, so you have to store it as you work your way through the call.
Let's say I'm looking for the number 9. We all know that it's here because we're humans and we can see that. The computer doesn't know it because the computer is very stupid. If we were to split this right in half, as of right now, probably be somewhere around there. Is 9 greater than, let's say it's 5. Is 9 greater than 5? It is. So I will end up with 9, and then the array will be 5, 6, 7, 8, 9, 10. I'll do it again. Cut it right in half. Let's say it's at 7. Is that it? It is. So I will get 7, 8, 9, 10. This will continue on until I actually hit the number. But at that point, if I return the index is going to be like 0. However, it doesn't keep in account, like, I've actually split it 1, 2, 3, 4, 5 times. I need to know how far I've already gone. So that's the idea. That's Alex's idea of, I have to keep track of how much I've already cut down. So Alex, how do I put that into my code here?
Your return statement, add in the
Midpoint number plus.
input.
So this one's it's only for the bigger half, right? If I'm not mistaken. Midpoint index, right? Plus that. Okay. All right, let's see. So we've gone through 1, 2, we're at 3 now. This number, if it's equal to, return this. If it's less than, return that. Repeat until either the number is found or there are no more numbers to compare against. I'm pretty sure this won't work, but we'll find out. Let's do, basically, it's kind of like, how do we do this last one? Basically, it's like, if we find the number, then return it, and that's what we did here. Otherwise, like, what should we do if there's no more numbers to compare against? What did the specs say?
Yeah, put the array dot length less than certain.
Yeah, we can do that. Else if array dot numbers array dot length is equal to 1. Return not found. So let's say I'm looking for the number 11 on this example that I have down here. I'll keep cutting down to the point where I have 1 number left. At one point, no matter what, there's only going to be 1 number left. If I found the number, then it'll execute this first, and then we'll be done. If it has a length of 1, at the very end, it would be, I'm looking for the number 11, and the only number left is 10. At that point, I'd say, like, oh, the array length is 1. I didn't execute these first 2 lines, thus it doesn't exist.
We couldn't do the we didn't put the test in there.
Okay.
I mean, there was a test in there, but the problem was, like, because we're adding a number to an integer.
Adding a number.
If you have, other return calls, let's say it was looking in the second half of the index, you didn't find it, you'd be adding a number to your not found.
So like not a number or something.
So you can't.
Okay.
Can't add, so
Maybe
we had to.
-1.
Yeah,
Not
we
there.
kind of just returned like a random value, and then we had a second call. Like, basically, we made a recursive function and a recursive helper function, and the helper function, took whatever the return is and said, "Is this actually equal to value?"
Okay.
Because otherwise, like the return -1. I mean, it's still going to give you an output, but it's not going to equal what you're looking for.
Yeah, let's put one more in here.
If this this index place equals the search number, then return true. Else,
So it was taking
basically it calls that recursive function. Like the helper function is the first one called. It calls the recursive function. Recursive function is called over and over again until it either finds it or doesn't find it. Then the helper function tests the return output.
Should we run these? See what happens? Okay. How do I run a Ruby file? Yeah, great. So I need to change into the Ruby. I can run a file using Ruby dot whatever, Ruby and then the file name. It won't do anything because I don't have anything in there. And then how do I run the spec files? So rspec is the command instead of Ruby. Okay, that stands for Ruby spec. I'm going to run it, and let's just see what happens. Hopefully all this works. Ooh. It says undefined method binary search for main object. What's going on here?
You gotta require the.
Yeah. So I have this spec file, but unfortunately the issue is I don't have none of it is actually going to work. So I'm going to require binary search to basically bring in all the contents of this file into binary search spec. Actually, this is not RSpec.
I was going to say, would
this
you
is
run
not,
that as RSpec?
I wouldn't run this as RSpec. It's actually not.
Okay.
That's a good thing for me to remember to change. Binary search.
We ran into Jasmine.
Nice.
JavaScript 2.
Not RSpec. All right, so let's list everything. So I'm going to do Ruby binary search spec.rb. Hopefully this returns a bunch of truths. And boo. Good. All right, let's take a look. It says require cannot load such file binary search. Oh, it's quite relative. It's require for Ruby gems like pry and things like that. We're going to cover a little bit more on that today. And it's require relative for files that you have written yourself. Please work. Not embarrass me. All right, so it says that there's an issue on binary search.rb, line 10. It says there's an undefined local variable midpoint over here. Let's take a look.
Midpoint index or midpoint.
Yeah. So it says binary search, line 10.
Midpoint dot.
Midpoint index.
And above as well, right?
That is correct, yeah. All right. Let's run this one more time. Uh-oh. I have something that says stack level 2 deep. What is that? What does that mean? We saw that twice yesterday.
Your base case isn't stopping. Somebody's code isn't meeting requirements in the base case. What the base case is.
I think that's accurate. Basically, what's happening is I'm running the program over and over and over and over again because I'm running it over and over again because I don't have that escape case. If you basically told if a child took you literally and you didn't tell it when to stop doing things, if you're like wash the dishes, like it would continue washing the dishes forever unless you said until there's no more dishes, wash all the dishes. I think it's this. I think this is in the wrong place. So I think what's happening is we're getting to the end. Like if, let's say we're looking for 11 and 10 or something like 11 inside of this array of 1 through 10. And it's going to continue executing and saying like the target number is larger than the midpoint. The target number is larger than the midpoint. The target number is larger than the midpoint. So I think this escape case of like, hey, if you get to the end and it's not there, you have a length of 1, return -1. I think this is the wrong place. So I'll move this up.
Is it just continually cutting the midpoint?
It can't. So there is a length of 1, and it's going to. So let's kind of go through it. So let's say we have the numbers. We're looking for the number 11, and the array that you're looking for is 10. Basically, what's going to happen is it's going to come here. It's going to calculate the midpoint index to be 0. It's going to calculate the midpoint number to be 10. And then it's going to hit this thing. It's going to say the target number is larger than the midpoint number. Thus, I'm going to do the midpoint index of 0 plus binary search of target number, which is still 11, and the numbers array is still 10. And I'm going to repeat that over and over forever. Work. Something's wrong here. It's no good. On line 12, binary search is too deep.
Check the spec file. There was something weird yesterday where, oh yeah, super big array isn't in order. One of them isn't in order.
That is an issue. So maybe that's one thing for us. We have to make sure that it's sorted. Otherwise, if it's not sorted, if I cut it right in half, then there's no real good way to do it. So maybe right away I will do numbers array.sort with the bang. What is the bang?
Destructive, or it mutates the original, so it actually saves it back into the original place, whatever the change you made was.
If we look at inside of Ruby array methods, we take a look inside of Ruby array methods, what we see is a whole list of all the methods that are available to arrays and hashes and strings and things like that. And what you'll notice about some of them, like the sort method, is that there's a sort without a bang, and that there is a sort with a bang. The sort without the bang will sort the letters or the numbers accordingly, but the original is not changed. When I do a sort with a bang, it'll change it. Like the output will be sorted, and the original will also be sorted. So maybe we will just do that, and I hope this works. We'll find out. Still no good. All right. Just for time's sake, I'm going to copy over my answer that I had finished earlier.
We kind of had some issues too. We sort of with the array at length too, and then just check the possibilities.
That is something we can do, yeah. So what did you say you did?
When it was linked to.
It was 2.
So like 2 or less should be.
Less than or equal to, yeah.
Then at that point, we checked, it's going to check the midpoint or check the seconds. So at that point, like, I would check for the second part of that. There'll only be 2 like numbers in that array, so
yeah,
just check both of them, and return 0 or 1, and that fixed our false stack.
Okay. I'm going to go. I like it. I'm going to go with this one for right now, just for time's sake. All right. So this is the answer that I have for myself. This is the binary search that I created. Basically, what I have here is a last index of 0. So I'm passing in an optional third argument. So if I don't pass anything for index, this is automatically going to be equal to 0. So I have very similar things, the same things as you. So I have the index, which is the array length.2. I can call this midpoint just for our sake. Midpoint index. So I have the index of like that middle number right there. And basically I'm saying if the array at the middle number, so it's like if the middle number is equal to the item, I'm going to return midpoint index, which is where I'm at right now, plus last index. If it's the first time through, that's great. I don't have to really worry about it. I'm going to just do, I'm just going to add 0 onto that. Else, if it's the array length is equal to 1, meaning I've gotten all the way to the end, I'm going to return -1. Else, if the number at the midpoint is greater than the item, the same thing as before. I'm going to return the item, the array from the very beginning into the middle, and then the last index, which is I think currently 0. Else, if it's less than, else if it's less than the item right at the middle, then I'm going to do the latter half, but I'm just going to add it into the last index. Let's see if this works. And then I think some people have to take off with Rod. for their one-on-ones.
I mean, do you need to press forward? You want to? I slot in a half hour for everybody, but it probably won't be that long for most.
Okay.
So if you want to go a little longer,
I can, yeah, I'll be done in like 10 minutes.
that's fine.
Yeah.
Then just whenever you're done, Alex, I'll meet you in the third floor. You know where it is? Just down the hall.
Okay.
And for those of you that don't know, I made chicken for you guys. Everyone has one in the fridge. If you don't want it, just give it to someone else. Jewel bag. So very fancy.
All right, so I just ran the specs. I got all trues and then one false. The one false is because this one is not sorted and I still need to sort it. So let's just do it right on sort on the first line. And then run one more time and we should have all trues.
Nice.
All right, I'm gonna stop this recording.
What was the